day, and I don't know how far we got here, but we're going to continue on here anyway, and we're going to get this done. We have to. So alkanes. Couple things to remember. There's lots of little key parts here that you want to remember. Hydrocarbon, any compound containing carbons and hydrogens, of course. Alkanes are saturated hydrocarbons. That means all the carbons, single bonds, hydrogens all the way around, fill up the rest. Okay, so that's a saturated hydrocarbon. Contains only single covalent bonds. Here's the first four alkanes we talked about last day, which of course are methane, ethane, propane, butane. Okay, and the general formula of alkanes is CnH2n plus 2. Okay, any set of molecules that differs by 1 is called a homologous series. And we then got into the naming of alkanes. Alkanes have three basic parts to them. Okay, the prefix, the root, okay, and then the suffix part. Really, when you start naming these or drawing these, you probably want to look at the root and the suffix first, because that's going to tell you how many carbons you have in that parent chain and what that parent chain looks like. Okay? So, if you had, for example, 1 carbon, you'd call it methane. 2 carbons is ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Okay? So, that's your first 10 there. And we said, let's draw some of these. And we did these, I believe. We did these though, right? Yeah. Okay, and so I'm not going to do a long thing here, but remember, octane, for example, look at this part here first, because that's going to tell you what it looks like. And you might say, well, yeah, but Mr. Bachek, they're all single bonds, I know that. Yeah, but they're not going to be, okay? That's going to tell you what you're looking at. That tells me it's saturated hydrocarbon, all single bonds. And this part now tells me that I have an 8-carbon chain. So I'd have 8 carbons, all linked together, and a bunch of hydrogens filling in the rest, yes? Okay, and we talked about that last. Good. Do I have to draw it again? No. Pentane. Once again, I say, hey, look, ane tells me single bonds, and I got 5, that's pent, okay? So 5 carbons in a row, hydrogens all the way around, okay? Then, of course, that's a little too easy. You can put on branches onto these, so you can add on some groups onto here, basically we call them, you still need to, and when you do this, you need to make sure that you arrive at those groups. So when you're naming these things, you need to arrive at that group as quick as possible. Okay, and we'll show you some examples of that happening. Branches are also known as side chains. So anything added on to that parent chain is called a branch or a side chain. The actual name for those is called an alkyl group, is what we call those, alkyl group. Common alkyl groups are these ones here. So if I added a CH3 onto something there, if I add that group on, we'd call that a methyl group. And if I added 2 carbons on, of course, well, 2 carbons in my parent chain would be eth, and if I'm going to add them onto a long chain, I'd call it ethyl. Okay, and then 3 carbons, if I'm adding that chain of 3 carbons on there to a main chain, I'd call it a propyl and a butyl, of course. Okay, so did we get this far? I think so. Okay, we'll just do a little review here. Here's my longest chain, which is what you need to find. Longest chain. Okay, this one happens to have 5 carbons in it, so right away I know single bonds, 5 carbons. That's pent, tane. Ane is the single bonds. And then I look here and I say, okay, how am I going to get to that add-on group as quick as possible? Am I going to start from the left or am I going to start from the right? So I'm going to say, okay, well, it's carbon 1, 2, that's carbon number 3. So it looks like on 3, I have this CH3 group added on. Or I could say, what about 1, 2, 3 from that end? Well, it looks like it's not going to make a difference, right? So there's only one right answer in this case, and that's, of course, on the 3rd carbon, I have what we call this add-on group. And that's 1 carbon, of course, CH3, that's called methyl. So that's 3-methyl pentane. Okay, that's all one word. There's no breaks in there. It's just that I kind of stretch that out a lot. Okay, so that's 3-methyl pentane. Okay, good. Any questions? I'm going a little bit quicker here because I know we kind of talked about some of this stuff already, yes? This one here, once again, remember, longest chain. So 1, 2, 3, 4, 5, 6. course, is an ethyl group that comes after methyl. But you have to get to this branch as quick as possible. You have to use the lowest numbers, basically, is what that implies. So the options are, I can start from here, 1, 2, 3, 4, 5, 6. Or I could start at this end and go 1, 2, 3. Which one's better? 3, obviously. So you want to get to that branch as quick as possible. So I would call this one 3-ethyl hexane. That's all one word again. 3-ethyl hexane. Okay? Good? Yes? Questions, anyone? Okay. When different types of branches are present, did we get this far? I don't think so. Okay, so when different types of branches are present, they are listed in alphabetical order. So we might be putting on a methyl group here, and we might decide to put on an ethyl group here, and maybe even a propyl group there eventually down the road, and we're going to get crazy, okay? We need to write that name out alphabetically, okay? So at the very end, it has to be arranged alphabetically is the key, okay? So it can get a little tricky here because it can kind of trip you up a little bit. So this is where it's going to get a little bit, you got to pay attention here. If there's multiple, and then that's kind of that's one statement there. This is a little different statement, but we will combine these two together eventually. So that's what we're going to do, but just be patient here. So if there's multiple occurrences, so let's say I put a methyl group here, and I put a methyl group here, I'm not going to say, oh, that's 2-methyl and that's a 7-methyl over there. I don't do that. I don't go 2-methyl, 7-methyl. I combine them together kind of thing because they're the same groups. And you might even have, eventually, you're going to have 2 and 4 and 7 methyls groups. Okay? We don't say 2, 4, 7, 2-methyl, 4-methyl, 7-methyl because the word's going to be like this long. And then we're going to have other groups added on. It's going to be this long. And then we're going to get to finally to the end name. We combine those together. We use these prefixes, di, tri, tetra kind of thing. So instead of saying 2-methyl, 7-methyl, we're going to say 2,7-dimethyl, which implies basically that there's 2 methyls and they are located on the 2 and the 7 carbon, for example. Okay? As one example. Or we got 3 methyls. So 2, 3, 4. So 2, 3, and 4 have methyls on them. 2, 3, 4, that's 3 methyls, that's trimethyl. You'll like it. Actually, don't. You'll probably die. Okay? So don't do that. So that's what you're going to do. You're going to put a little prefix in front of there as far as that goes. However, and we're going to get to this in a second here, when you do determine alphabetical order with those, because you're probably going to have some other stuff. It's going to get crazy here, guys. Oh, it's going to get good. I'm telling you. You know, it's not all about octane. If you can draw octane, yay. But it's going to get a little more complex. But it's all good stuff. Well, it's drawing. It's art. Everybody loves art. Okay. Di, tri, tetra are not alphabetical. So if it has dimethyl, I don't care about the di part. That's not alphabetical. That has nothing to do with the alphabetical order. It's still based on the alkyl group. So methyl and triethyl, for example, ethyl is what I'm looking at, not the tri part. So it's ethyl versus methyl, alphabetically. Okay. So for example, dipropyl would still come after ethyl because propyl is a P, ethyl, of course, is E. You kind of got to know alphabetical order, I guess, is what I'm saying. Okay? So ethyl would come before dipropyl in the naming. I'll show you some examples. Here we go. Name the following compounds. Let's do that. It looks like fun. As always, you're going to start. Where do you start with naming these? I would start by looking for the longest chain of carbons, right? Always, always. So I look here and I say, what's the longest chain of carbons? 1, 2, 3, 4. Yep, that's an option. 1, 2, 3, 4. That's an option. 1, 2, 3, 4. That's an option. I'm going to go with this one, though, because it's probably the easiest one. Okay? So 4 carbons is the longest chain I can make. 4 carbons, all single bonded. So I know 4 is bute. Single bonded is ane. So that is butane. Dun, 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 butane. All right. then I want to get to those groups as quickly as possible. So I could start here with 1, 2, 3, 4. That means that 3 would have these methyl groups. That's not going to be as quick as possible. I want to start here. 1, 2, 3, 4. What's on the second carbon? I have a methyl group up here, yeah? And I also got one down here, correct? So on the second carbon, I have a methyl, and on the second carbon, I have a methyl. So how am I going to represent that? Well, you have to use numbers for both of them. You always have to use the numbers. So if it's dimethyl, you need to use 2 numbers. If it's trimethyl, I need to see 3 numbers because you do have to tell me the location of those methyls. And you might say, well, but they're on the same one. Why can't I put 2? No, it doesn't work that way. Because there might be a 2 and a 3, for example. Or it might be 2, 2. So you have to be specific for each one group that you're putting on. Each group needs a number, okay? So I'm going to put on here 2 methyl here, and 2 has a methyl, so that turns out to be 2 and a 2 have methyls on them. So I put 2, 2 dimethyl, okay? And you might say, well, you know, once again, do I need both 2's there? Yes, you do, okay? Do I need the di there? Yes, because you're telling me that on 2, there's a methyl, and 2, there's 2 methyls, dimethyl, and they happen to be on 2 and 2, okay? So you do need all that. That's all, once again, one word, 2, 2 dash dimethyl butane. All one word, okay? Because I don't know if I told you, but there is one where there's going to be a break in the word that's different, and that'll be a key for you later down the road. But these are all one words, okay? Let's find the longest chain here. Let's see. 1, 2, 3, 4, 5, 6. Yeah. What about 1, 2, 3, 4, 5, 6? That's an option. What about 1, 2, 3, 4, 5? That's an option. Right? Remember, you can zigzag up and down. You can do a U. You could do upside down. You could do this kind of like, as long as you can continue the line, it's all good. Okay. So be careful of that, because I know there's going to be questions where we're going to give them to you, and you're going to be like, oh, everyone goes right for this one, right? Because that's the money shot right there. Oh, that's easy. Right? But it's not gonna be, because you might have to go and then up and over, or up and down, or you might have to start down here and go up and over and up and over. It's gonna be fun. Okay? 1, 2, 3, 4, 5, 6. Is that right? 6. So single bonds. 6 is hex. Ane is single bonds. That's where I would start. And then once again, you have to use, you know, you have to get to those branches as quick as possible. Well, this one, this is what I'm talking about. This is going to get interesting. We got 1, 2, 3, 4, 5, 6 is your option. But I'm naming that longest chain. Okay, so that's one option. The other option, of course, is 1, 2, 3, 4, 5, 6. The question becomes, which one is going to give you the lowest numbers? Which one are you going to get to first? And you might say, well, looks like 3 and 4 is probably a safe bet, yeah? But which way do I start is the question. Do I start from the left or the right? Which one ultimately is going to give you the lowest numbers? That's what you need to worry about. Which one do you get to the chains fastest at? You might say, I get to the chain fastest from this one, this is a 3, and I get to the chain fastest this way, it's a 3. So now what? But you got to use the lowest numbers. So how are you going to use the lowest numbers? Left or right start? Left. Because look, 1, and if you, by the way, guys, here's another little tip for you. If you get kind of confused now and you're like, there's a lot of stuff going on here, okay? You can always do this. So I start with that, hexane, and then off to the side somewhere, if you want to write down all the groups that you're adding on and then organize them appropriately, that's not a bad idea. Because remember, you still have to organize them alphabetically. There's lots of stuff going on here. So here, look, 1, 2, 3. So 3 and 3 have methyls, yes? So that is called 3,3-dimethyl, right? Correct? Yes? 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 3 and 3 have methyls, so 3,3-dimethyl. So if I am going to go this way using the blue numbers, and I had 4 here, what's this group here? Ethyl, right? 4 is an ethyl group, okay? Now look, I'll do the other one and I'll show you, okay? But that's not a bad thing if you want to do. If you can't do this all in one step, that's okay. I'm not asking you to. Write it down somewhere and then put it all together. Look, if I use the green numbers, what happens? Well, I'm going to start this end now. What do I get? I get 3 ethyl and 4,4-dimethyl. Yes? Okay? That's starting at the right side. That's the green numbers, yes? Which one uses the lower numbers? 3, 3, 4, right? Are lower numbers than 3, 4, 4, correct? Not by much, but they are, right? So I got to go with 3, 3, 4. Lowest numbers, I have to use the lowest numbers. I have to get to that branch first. So the answer is, I got to go with this one here, okay? Not that one, okay? Now, once you've done that, remember, I got to write this all out here. So actually, I'm just going to take a little extra space here. I already said it was hexane. You guys agreed with that. Now I got to write those 2 in front of it, okay? And those 2 in front of it, of course, now it goes based alphabetically, yes? So, what comes first, dimethyl or ethyl? Ethyl comes first because we don't include the di prefix. Ethyl comes before methyl. The di has nothing to do with it. So ethyl group comes before the methyl group. So I have to, in fact, write 4 ethyl. Okay? You're going to put a dash here, and you're going to put 3, 3-dimethyl. Hexane. All one word. Okay? 4-ethyl 3,3-dimethyl hexane. Okay? That's the little trick here. You have to get to the branches as quick as possible, but when you go to put the actual name down, you have to do it alphabetically. That might not match up. Some people are unhappy that this 4 is out in front of these 3s here. Some people are like, I don't know, I don't like that. Well, too bad. Okay? It's alphabetical. There's nothing I can do about that. If this was a 7 and these were 1s, but this is alphabetical, then I got to go with that. Okay? And I mean, some of these things that I tell you are probably impossible almost, but I'm just being a little silly. But you know, if it's 7 versus 1 and 1, well, and if it's alphabetical, I got to go alphabetical. It might even go 5, 4, 3, 2, 1 alphabetical. Okay? Well, there's nothing you can do about it. Okay? But you do have to get to these branches as quick as possible. That's the rules for naming them. Okay? So, good? Drawing. Oh, everybody loves drawing. Hey? Oh, I'm ever so good at drawing, Mr. Bachek. I'm going to rock this. Yeah, drawing's way easier. I'm going to tell you right now. Hey? It is. It's easier. You're going to draw out the parent chain, right? Where did I tell you always to start? You always start at the end, right? Single bonds, how many carbons in a row? That's what I do. And then attach stuff to it, right? So here, look. 3-ethyl, 3-methyl pentane. I can do that. Okay, I start at pentane, yes? So pentane looks like this. 5 carbons in a row, single bonds. Pentane is where I would start. Okay, and if you want to make yourself little notes for this stuff, by all means do so. Pentane, that's where I start at. I start at the end because that tells me how many carbons in a row and what kind of bonds I have between those carbons. So pentane. And then what was it? Sorry, I forgot already. 3-ethyl, 3-methyl. Okay, so on the 3rd carbon I have an ethyl. On the 3rd carbon I have a methyl. Okay, so you know, can you start from this end or this end? I don't care, whatever. I start from this end because I like to do book stuff. I do lots of reading. 1, 2, 3, ethyl. I'm going to put my ethyl down here because I want to, and you can't stop me. And I'm going to put my methyl up there because I want to. So 3 has an ethyl, 3 has a methyl. Okay, I put 1 below, I put 1 above. Obviously, it gets 3, 3, right? So that's that, and then I fill in the rest with H's. H3, H2, H2, H3. There you go. Okay? Now this is the important part, of course. Make sure you can get that, because of course you might say, is the entire Unit 3 test going to be drawing? No. That's too easy, right? Is the entire Unit 3 test going to be tougher than that? Yeah. I don't know, much tougher, but listen, what are we going to do with this now? I'm going to say to you, oh, let's use a little Unit 1 review stuff. We'll give you some practice with that. If I was doing the combustion of 10 grams of 3-methyl pentane, given that the molar heat of combustion of 3-ethyl 3-methyl pentane is 20 kilojoules per mole or something like that, what's the enthalpy change associated with that? Delta H, hey? Yeah, it's going to be awesome. Just wait, it's going to get good. Yeah. Yeah. All right, so there's that one. What do we got? Oh, we're doing good for time. What's the next? Oh, sorry. What's the next one there, somebody? 3,4-dimethyl. I can do this one. 3,4-dimethylhexane. Okay. 3,4-dimethylhexane. Hexane is where I want to start because that tells me 6, 3, 4, 5, 6, 3, 6, right? Hexane. And I forgot already. 3,3-dimethyl. Is that it? Oh, 3,4. Okay. 3,4-dimethyl. Okay. So 1, 2, third carbon's got a methyl. Third carbon's got a, or fourth carbon's got a methyl. There you go. Okay. People are asking me, can you put them on top, Mr. Bachek? Yeah. Don't. Yeah, absolutely. You just flip it over, right? The same thing, right? Some people are saying, hey, can I flip this one over? Can I put the ethyl on top and the methyl on the bottom? Yep, you can. That's fine. Okay. Fill in the rest with H's. And once again, Connor told us the other day here that, what are we going to do with this stuff? We're going to burn it probably, yeah? Everyone likes burning stuff. Absolutely. Right? Octane. They put that in fuel, etc., right? And so on and so on. We're going to probably burn it. So the problem with that is make sure you put on the right number of H's, obviously the right number of carbons, because we need to get the right molar mass so that we get the right number of N, so that we get the right number of answer. Yes? So there's 2 there. There'd be a 1 there. There'd be 1 there. There'd be 2 there and 3 there. Every carbon needs 4 things around it. Okay? So just keep that in mind. All right? Good. Yes? Physical properties. Now, people don't like studying this part because this sucks, right? I want to draw stuff, and I want to, and then some of you guys actually like naming them because you're kind of weird, okay? I said it. There you go. You're going to like to draw or name stuff. That's fine. But this is going to be the difference here, okay? You need to know this stuff because this is going to be the little subtle things that we put into there to make sure that you guys know everything about an alkane, for example. Okay, so this stuff is important, absolutely. Mine got really cut off here, but it says something about, I kind of forget here, but it says something about basically intermolecular forces, London forces. Alkanes are nonpolar. That's not the right one. Alkanes are nonpolar. That's fine, I got one there. So the only force in them is intermolecular forces, is London forces. London forces are based on 2 things, size and shape, yes? Chem 20. So linear is good, right? Think of this, linear, right? Or linear, right? Linear good, yeah? Linear long, right? Linear long, linear very flat, very linear, right? Which means mucho, I don't know why I'm talking like, I've almost done my coffee though, so this probably explains a few things. Mucho, and there's mucho linear, which means basically lots of surface area, right, to contact. Linear, very good, right? Lots of contact area. This one holds together, this one very good. Well, if it's long, then there's lots of linear surface area contact. So the longer they are, the better they are, Better at what? Well, better at sticking together, better intermolecular forces, better London forces, higher melting boiling points, yes? Are all a result of that. What also happens when you get long chains like that? How do I make long chains? Well, how do I make this chain? 2 carbons. Oh, they're so cute. How do I make linear chains? Like 10 carbons, yeah? So the size goes up too, right? I don't know what's going on. Brad's sleeping there. I don't know. Hey, Oh, focusing. Long chains, okay, like 10 carbons. Well, what's the deal with 10 carbons? 10 carbons, how many electrons are floating around and around in there, right? London forces are based on two things. Size, how many electrons are going around and around, because that's what leads to temporary distortion, temporary dipoles, temporary partial positive, partial negatives, temporary attractions. So the longer the chain is, the more electrons you have floating around, the better chance of distortion, right? The better chance of London forces. So because of that, as the length of the chain increases, the intermolecular forces build up. And as a result of that, because there's more intermolecular forces, there's more higher melting boiling points, okay? This is what I'm trying to say. What else did it say there? Alkanes are nonpolar. So remember that. They are nonpolar. And as a result of nonpolar, by the way, and then they just talk about, this is a little bit tougher, okay, and we don't really expect you to know that, although you should know that the little ones, like CH2, CH3, ethane, methane, you can get to propane, obviously, for barbecues, you probably know as a gas, butane for lighters, we're getting close there, but that is technically a gas, okay? When you get the pentane, and I don't expect you to know this cutoff, but I'm just saying the small ones are gases. As you get a little bit longer, intermolecular forces build up, so then they turn to liquids, like pentane is a liquid. And then hexane's a liquid, et cetera, et cetera. And as you get farther and farther, longer, then they turn into solids eventually, okay? So you got gases, you got some that are liquids, you got the higher ones are probably solids, okay? All alkanes are saturated hydrocarbons. They are nonpolar, so they are not soluble in water. If you put pentane, which is a liquid, into water, you would see probably two different liquids in there. Pentane would be, it doesn't break it down into individual molecules to disperse through the water. Pentane and water would be two different liquids in there, okay? Yeah? So, what I would do with that stuff there, we're running out of time here, but just a minute, I got some stuff for you here.